How you doing, everyone? For this video here, we're going to create snake as a Java applet, and here's what the finished product will look like. We'll have our nice little snake, essentially just an array list of points, and we're going to go around and collect these little green tokens. Each one that you collect makes the snake longer, and then finally, if you run into a wall or the snake hits itself, we'll say game over, and then it says how many tokens you've actually collected. But here we go, let's get into it. Now, this game requires several classes. The first one that I'm going to create is just the point class. There is a point class already created in Abstract Window Toolkit, but I'm just going to create my own, very simple one quickly here. We'll say private int x, y. Then let's add in a default constructor. Here's just public point, initializes x and y to 0. Let's create a second constructor that takes in an x, takes in a y. We'll assign those to our instance variables. And then let's just create mutators and accessors for both of those. Okay, and there we have it. That's our entire point class. So now we can move on to the other classes. And the next class we're going to create is going to be snake game. So we'll just say new class, snake game. Now this is the one that's actually going to be an applet. So we can put extends, applet. And this is the class that will actually be able to control the size of the applet as well as the background. Inside here, we'll create several methods. The first one is going to be public void init. The next one's going to be public void paint. This one's going to have a graphics G as a parameter. We'll make a public void update, again with a graphics G. And we'll add one more method, which is going to be repaint, so public void repaint, and one more time with the graphics G. Now we have to do some imports, so just go ahead and import graphics. Okay, looks good. Now, this is going to be an applet, but it's also going to be a runnable applet, so we're going to have to implement runnable. And once you implement, it'll prompt you to add the unimplemented methods. So when I do that, all I do is click on add unimplemented methods, and it will automatically put in any methods that the interface requires you to implement. For this one, there's only one method, and it's just the run method. And we almost have all of our methods. We're also going to implement key listener, and this just enables us to get information from the keyboard. So we'll import key listener, and then do the same thing, click the error, say add unimplemented methods, and it should paste 3 in there for you, which are key pressed, key released, and key typed. Alright, let's knock out some of the simple setup now. For these two, all we're going to do is just call the paint method again. So we can say paint, G, same thing with repaint, just call the paint method, G. And now really you can just minimize those. We're done with those. That's as much as we're going to do. Now we can go into init and we can specify the size of the applet. We're just going to say this dot resize, and then you can specify the size. I'm going to just make it 400 by 400. That'll make a nice small applet. We should actually even be able to run now, and it should show us at least the size of our applet. It should be 400 by 400. Here it is, and this is what the size of the snake game will look like. Let's also put our background in a while. I'm going to say g.setColor, then I'm going to set the background as black. Looks good, and then we'll say G fill rect for fill rectangle. Now the X and Y specify where the rectangle is going to be drawn. Well, we're going to draw it at 0, 0. Remember, for applets, 0, 0 is the top left corner, and then we're just going to make it the entire background. So the width will be 400, the height will be 400, so the entire background should now be black. And there we have it. Now remember, when the applet starts, it automatically calls init and then it calls paint. So that's why it's automatically setting that background to black right now. And while we're here, I'd like to set up the double buffering as well. So in order to do that, I'm going to create a graphics and an image. You'll have to import image. Then we can go ahead and actually create these. We'll create the image first. We'll say img. We're going to create image, just the same size as our applet. And now that we have that, we can create our graphics. And we'll just say image get graphics. And now this represents our off-screen image that we'll draw, and then we're just going to copy that whole off-screen image right onto the screen. And we can do that by modifying the paint method. These G's will become the off-screen graphics, and then down at the bottom we can paint the entire image right at one time by saying G, draw image, and then img, we're going to paint it as 0, 0, and then for this last parameter we can just type in null. And the final thing we can do before we create our snake class is we can set up this key press method down here. So this is just going to be set up to coincide with when the user presses up, down, left, or right. That should control our snake. So I'm first going to change this parameter to E just to simplify things, and now we can say if e.getKeyCode equals key event vk, and now you should have a choice of vk up, vk down, vk left, right, so on. And now just copy and paste this several times. Good, and we should have 4 of them. 1, 2, 3, 4. 4 of them for up, down, left, and right. And then we can just simply change this end. And now the next thing we need to add is a snake class. So new class, snake, and really our snake is just going to be represented by a list of points that can be modified. So every time the snake runs over a token or runs over whatever the target is, really, it's going to elongate, and we can just add another point to the list, and then we'll just draw the whole list. So we'll say list with a type parameter for point, we'll call it snake points. And then we'll finish instantiating inside the constructor. We can say snake points equals new array list, type parameter point, and then we'll just have to import both of these. Alright, very good. And now we need to add integers for an x direction and a y direction. So int xdir, ydir. And the way I'm going to work this is that if the x direction is -1, that means it's heading to the left. Remember, 0 is on the top left corner. If the x direction is +1, it's heading to the right. If the y direction is -1, it's going up. If the y direction is +1, it's going down. And if the directions are 0, that means it's not moving in that direction. So we can start it out with both of them at 0, meaning that the snake is not moving. And we can code the snake's draw method a while. It's just going to be public void draw. It's going to take in a graphics G, and this will just enable us to create a snake object in the snake game, instantiate the object, and then call the draw method passing the GFX graphics that we have within snake game. So in here I'm going to make my snake white. So I'll just say g.setColor, color.white. After that, now all I'm going to do is draw each point within the snake. So the snake is made up of several tiny rectangles, which when they're all lined up makes up the snake. So I'll say for each point P in snake points, now I'm just going to fill each of those rectangles, and the x and the y will be p.getx, and the y will be p.getY. And then for the width and the height, I like to do 4. If you do 1, your snake looks incredibly small, so doing each small rectangle as 4 by 4 gives your snake some actual size. Now, to complete our snake class, there are several more methods that we need to add. First couple being we need to create accessors for this x direction and y direction. So public int get xdir, Then we'll do the same thing for y, public int get y_dir. Now we're also going to create setters for these as well, so it'll be public void set x dir, and we'll take in an integer. Do the same thing for y, and looks good. We also need to create two more methods that allow us to get the x and y position of the front of the snake. Now the front of the snake is always going to be element 0 of this list. So that will always be the head of the snake. So I'm going to create a method called public int get x, and this is going to be the x position of the head of the snake. And in order to get this, we're just going to return snakepoints.get0.getx. So it gets the first element in the list and then returns x. We'll do the same thing for y, public int get y, return snakepoints.get0.getY. Now we need to make some booleans, so we'll go up to the top. Let's say boolean. First one's going to be is moving, just to keep track of whether the snake currently is moving or not. Now we want to use this just off the start, and we're only going to set it to start moving if they press 3 of the 4 directional keys. What I mean is that when the game starts, we want to have the snake facing a certain direction, and then they can only go the 3 other directions. They can't go back the way the snake is immediately facing. So we'll say is moving. We're also going to create a boolean called elongate. So this one will just dictate when the snake should actually increase. So as soon as it hits one of the tokens, then we should hit the elongate boolean, and that will make the snake longer. We'll set both of these initially to false inside the constructor. Alright, a few more steps and we'll actually be able to see our snake on the applet. First thing we have to do is actually specify where the snake is going to start and how big the snake is going to be. So I'm going to say final int, and we'll say size. I'm going to put it at 20, meaning that it's 20 tiny rectangles long. Then I'm also going to make start x at 150, and we'll make start y also at 150. Very good. So this is the start position, meaning that it's going to come down 150 over 150, and that will be our first point of the snake, or the front of the snake. So to do this, now inside of here, we're going to start adding on to snake points. So I can say snake points dot add new point, and this new point is just going to be the start x and start y. And now that we have our first point added here, we can add the rest of the points for the snake for the initial startup, and we'll just use a loop to do that. Now for the loop, I'm just going to say int I is equal to 1. Normally we'd start at 0, but we already have our first point created right here. Now I'm going to say I is less than the start size, which we have a final variable for that, which is just size. Then I'll do I++. Inside the loop, we're going to say snake points.add new point. Now let's just type this in for now. I'll explain it in a second, but we're going to say start x minus I times 4 and then start y. Now, explanation for this line here. We have start x and start y, which just represents the starting point of the snake. So once you run the applet, it'll be at 150, 150, that'll be the head of the snake, and then we're going to push the body out to the left. Remember, the snake is made up of tiny rectangles that are just 4 by 4, so we offset each point by 4 and then subtract it. So that'll push the body out to the left. Each time it iterates, it just subtracts a greater multiple of 4. We left y the same because we wanted to just start out horizontally, and then you can pick your direction from there. There's one more thing that I'd like to change here. This size variable would make more sense if we would change it to start size, because the actual size of the snake is going to change. But very good. With that, we can go back to snake game, finish doing some setup for this class. Since this is runnable, we need to create a new thread in here, so we'll say thread as a global variable, finish instantiation inside of init. We'll say thread equals new thread. We're going to pass a parameter which is a runnable object. Well, snake game itself is a runnable object, so we can just pass this. Then we can say thread.start to start the thread. Then let's go down into our run method. Now, the big thing that's actually running the game behind the scenes is this infinite for loop that we're going to place inside of the run method. So inside the infinite for loop, we're just really going to draw over and over and over, and it's going to be much like a picture book where it just displays picture after picture, but if you flip through the book fast enough, it looks like things are moving. In here, we're going to create a time delay, so we can say thread.sleep, and we'll just set it for 40 for now. And it's going to make you surround this in a try and catch. You can just click the arrow, click surround, try catch. Alright, we're looking pretty good. We're almost at the point where we can draw our snake. We need to first create a new snake object. So I'm going to create it as a global variable again. We'll say snake. Inside of init, we'll initialize the snake. Snake equals new snake. Inside of paint, make sure that this draw image is your last line, and then we'll say snake.draw, and remember that draw method takes in a graphics, and we're going to pass the off-screen graphics rather than the on-screen G. Finally, down here, we're going to just call this.repaint, and now we should finally be able to run, and it should show our snake. So here we go. There we have it. Here's the head of the snake at 150, 150, and then it just goes off to the left. Now, the next logical thing to do is to get this snake to be able to move. So we're going to go back to the snake class, and inside the snake class, wherever you like, we're going to create a new method. It's going to be called public void move. Now, move is going to get called inside of that infinite loop that we created in snake game. So every time that infinite loop iterates, it's going to move the snake. It'll draw the snake, and it'll briefly pause so that our eye can pick up that the snake moved. So now inside of move, we need to first record where the snake currently is so that we can create the new positions and the new points for the snake. So we're going to say point temp is equal to snake points dot get 0. So this is just recording where the start of the snake currently is. We can record the last point as well. So point last is equal to snake points dot get. To get the last point, you're just going to have to do a snake points dot size -1. And now we're ready to create the new starting point for the snake. So we'll create point new start is equal to new point. And in here, we're just going to grab the temp x position, so temp.getX. And then it's just going to be plus x direction times 4. We'll talk more about that in a second. And then comma, we need to do the same thing for the y, temp get y plus y direction times 4. Now this represents the new starting point for the snake. And if you think about it, it's very similar reasoning to what we did up here. Since our rectangles are 4 by 4, we're just going to either add 4 or we'll subtract 4, or if the x direction and y direction is 0, it won't add anything at all. So it's always going to be in multiples of 4. Add 4, subtract 4, or not do anything. Okay, so that was the easy part. Now we need to work on updating every single other point. We know what the new start point will be, but now we need to get every other point to move as well. So let's just say the snake moves to the right. That means every single point needs to be shifted to the right by 4. And we'll use a for loop to do this, but when we use our for loop, we're actually going to iterate backwards through the snake. And what I mean by that is we're going to start at int I is equal to snake points dot size -1, and then we're going to go while I is greater than or equal to 1, and we'll do a minus minus at the end here. So now the idea behind this is that every snake point becomes the snake point that it was in front of it in line. And then as long as we do this over and over and over and don't overwrite anything, then we should be good to go. So this is why we're doing it backwards. Every point just becomes the point that was before it. So in here, let's actually modify all of the points. So we can say snake points dot set, and we're going to set whatever index we're currently at to snake points dot get I minus 1, which is the index before I. So this will update the entire body. The last thing that we need to do is just update the original head of the snake, and we can say snake points dot set 0 to new start, since we already figured that out up there. And now we're looking pretty good, so let's go back to snake game here. Inside of the run method, inside of our infinite loop now, we're going to tell the snake to move. So we should already have that global snake variable. We'll just say snake move. Then after the snake moves, we'll get a repaint. But you can run right now, but the snake still won't move. We need to next add our keyboard interaction. So the next bit of coding we'll do is in the key pressed method of snake game. Now within each of these, the classic game snake really dictates how you can move. And the way that it dictates this is it says if you're going up, you have the options of going left or right, but the snake can't really ever stop. There's no way to stop. You're always moving in some direction. So once you start moving, you're always moving. So here's what we need to do. We need to say get key code, key event up. So if they press up, we're going to say if their current direction is not equal to 1, so snake.get y direction is not equal to 1. In other words, if they're going down already, then you can't go up. You can't just reverse your direction, because then you'd be running into yourself. So as long as they're not going down already, then we can allow them to go up, and then we'll actually set their direction here. So we can say snake.set y direction -1. Good, and then this automatically needs to set the x direction to 0. You cannot go diagonal in snake. It's not possible. You can't go up and to the left, you can't go up and to the right. You're either going up, down, left, or right, and those are your choices. So we can say snake.set x direction 0. So one more time, this just says if the snake is not going down, remember 1 represents going down, -1 represents going up. So if the snake is not going down, we will allow the snake to go up, and we will change the snake's y direction to going up. And then we're going to set the x direction to having no direction. It's not going to be going either left or right. Now that we have this guy coded, the next ones are easy. We can just copy and paste. Since we're going down now, we just want to make this a -1, meaning we're not going up. We can change this to +1. That will remain the same. Very good. And then we can copy and paste again for these two. Now be careful in here. You'll have to change your x's and y's. So change x, x. This will be y. Do the same thing down here. X, x, y. And that's actually all we need to do for the right side. We just need to change the left here. This should be +1. Make this guy -1, and now we should be good to go. Now we can go ahead and run our applet, and good or bad, our snake should have some functionality, so go ahead and run. Okay, so it ran, but it looks like our loop inside of our move method just ate away at our snake. So all it did was took each point and updated it so that it was the point in front of it, which is exactly what we want it to do. It's just that we only want it to do it when the snake is moving. So this is where that is moving variable inside of snake comes into play. So we have this boolean is moving. Initially it's set to false. So we need to come down inside of our snake move method that we just coded, and we need to make sure that this only happens if the snake is actually moving. So we should put an if is moving here, and we can just put all of this inside of this. Looks good. Go ahead and run. Okay, so now our snake doesn't move. It doesn't eat away at itself. Very good. Now we're doing pretty well. We have all of our keyboard controls coded. Once we run, it starts in the starting position. It doesn't eat away at itself. And the only problem is now that once you actually hit up, down, left, or right, the snake doesn't do anything. So we need to figure out how to make it do something. In order to do this, this is where we're going to start using our isMoving boolean, and it's actually going to be controlled from snake game. So we're going to create accessors and mutators for that Boolean variable. So public Boolean is moving, so that we can access this in snake game, and we're just going to return the is moving Boolean. And we're also going to say public void set is moving with a Boolean b here, and we're going to take in, we'll say is moving is just equal to whatever they input. So let's head back to snake game now, and let's actually use that to tell the snake when it's moving. This is going to happen at the very top of key pressed, and we're going to say, well, if you press some key and the snake is not moving, so we're going to negate this guy. So if you press a key and the snake is not moving, and you press up, right, or down, we're going to start the snake moving. Since the snake is initially facing right, we're not going to include left in that. So in here we're going to say if e.getKeyCode is equal to key event up, yep, good, or, then we're just going to do ors, and we'll do right, and then we'll do down. Okay, so there's our final if statement. Very good. So if the snake is not moving, you press one of these keys. Now we can finally tell the snake that it is officially moving. So we can say snake dot set is moving to true. And now we can go ahead and run. Snake is sitting there in the starting position. You can hit your arrow keys, and after all of that, it still will not move. So there's just one more line that we have to add. Go ahead, go up to init. Inside of here, we're just going to add the key listener to the applet. So we'll say this dot add key listener, and we're going to pass a parameter as this. So now we can finally run. To start it off, just hit up, down, or right, and there we go. Our snake is officially moving. Its behavior looks like the classic snake game. Looks good. But now, before we get too happy, there are many things we need to fix as far as the snake's functionality. So let's think about what ends the game. What ends the game is if you hit a wall or the snake hits itself. Right now, you can do both of those things and it won't matter. I just hit myself, doesn't matter. I can actually go off the screen. Now I can come back on the screen, go off the screen, come back on the screen. Doesn't matter, we have full ability to do all of these things. So we need to start telling the snake what's going to end the game. And the coding for this can just get done inside of snake game. We're going to create a Boolean called game over. Game over will initially be set to false. And we're actually going to create a new method. I'm going to put it right below run, and we're going to call it public void check game over. There are several things that can cause the game to be over, so we'll just call this method every time the loop iterates just to make sure that the game is still running. No one's violated any of the rules of snake. So let's actually call this method now. We'll put it right below move, so the snake will move, then we'll check if the game is over. We can say this dot check game over. Good, and that will send us into this method. So inside of here, we're going to check the X and Y position of the snake, which is really just the X and Y position of that starting point of the snake. So I'll have two starter if statements in here. First one will be for the X position. I'll say if snake.getX is less than 0, meaning it's gone off the left side of the screen. And then we can also say if snake.getX is greater than, now here you might want to say 400, but we actually need to take it 3 less than that and put it at 396. Remember, when the rectangles are drawn, they're drawn from the top left corner. So if you're at 396, you're okay, you can still see the rectangle, but as soon as you hit 397, that actually puts a portion of the rectangle off the screen, or a portion of the snake off the screen. So if that happens, then the game should be over. So if it's either less than 0 or greater than 396, we'll just say game over is equal to true. Then we're just going to copy and paste this thing. We'll do the exact same thing for y. So those are the first two conditions that will end the game. There's another third condition, and that's if the snake hits itself. In order to do this one, we're going to go back to the snake class, and down below move here, I'm going to add another method. It's going to be public boolean snake collision, meaning that the snake has collided with itself. In order to do this one, we just need to track the starting point or the head of the snake and see if it is the same x and y position as any of the other points of the snake. So within here, the first thing I'll do is just record the x and y position of the head of the snake. So I'll say int x is equal to this.getX. We can just use that helper method we already created. Then we can say int y is equal to this.getY. Now, we're going to loop through here, but we need to start at the first element rather than index 0. We need to start at index 1 and go from there so that we don't check to see if the head is equal to itself. So we'll say for int I is equal to 1, I is less than snake points dot size I plus plus. Good. So now inside of here we'll say if snake points dot get I dot get x is equal to the x that we just figured out up there, and snake points dot get I dot get y is equal to the y that we reported up there. If they are equal to each other, that means a snake collision has occurred, and we're going to return true then. And if it makes it the whole way through the loop and that doesn't happen, then we can just return false. So now we'll go back to our snake game class and we can just add this in, say if snake.snake collision, that returns a boolean. So if that occurs, then game over is equal to true. So now we've figured out all the instances in which a game over will occur. So now we need to tell it to paint something different if a game over actually happens. So if the game's still continuing, it'll just do the normal paint, but if the game is over, then we're going to stop it, we'll remove the snake, and then we'll just show game over and how many tokens you've actually collected. So here we go. Inside of here, we first need to tell it when to draw the snake. We'll say if not game over, draw the snake. Otherwise, then we're going to change the color. I'm going to say color.red. So this will be for the game over text, and we can say graphics.drawString. Then in here we just specify our text first, so game over, and I'm going to put it at 180, 150. And this will only happen if game over actually occurs. Now we can actually go down to our move where the snake is moving, and we can tell it to do the same thing. We only want to do this if the game is not over. So if not game over, then we can go ahead and do these two things. Alright, so let's test it. Let's run smack into a wall. There it is, cause the game to be over. Good, let's run it again. We can test our snake collision. Let's run it into itself. Good, picked up that as well. You should be able to test every side wall, run into it, and it should give you a game over. Alright, now the last thing we need to actually add in before our game is complete is just this token class, and that's what the snake is actually going after. So the snake is attempting to collect as many tokens as it can and get as long as it possibly can. Each time it collects a token, it makes the snake 1 bit longer. So let's create the token class. Say new class, token. And this class is going to have several instance variables. First, it's going to have private integers for x, y, and the score. So this is where we'll actually keep track of how many tokens have been collected. Then we're also going to have a private snake variable, just so that we can see where the x and y position of the snake actually is. Let's go ahead and create our constructor. It is going to take in a parameter. It's going to take in a snake as a parameter, and we're just going to assign that to our snake instance variable. Let's also create an accessor for the score. It'll just be public int get score, and we'll return the score instance variable. Now, the idea behind the token is that we'll instantiate the token once, and then once the token is instantiated, it's instantiated with an x and y position that are random somewhere within the applet. So within the 400 by 400 applet that we have, it's going to create this token, and then the snake has to chase it and then run over the token in order to get longer, and then we'll add one to the score. Before we do any of that, I'd like to do the draw method first. So let's do public void draw. Again, this will take in the usual graphics G. Inside of here, we can say set color. I'm going to say green. And we'll need to import. Alright, very good. And now we can actually draw, so let's say G, fill rect, all it is just a rectangle. And we're going to put it at the XY position, and then we're going to make, you can really do whatever width and height you like. I'm going to set it up for 6 by 6. So it's actually larger than the head of the snake, so the snake will have a couple options in the way that it can hit it, and it'll be bigger than the actual point of our snake. Now that we've established that it's going to be a 6 by 6 rectangle, it will make more sense if we go up to the constructor, and now we can code the random x and y position. So let's say x is equal to, it's going to be an integer, and then it'll be math.random. Remember, that creates a random from 0 to 1, some decimal. Well, let's multiply that by 395. So what we really want is a random number between 0 and 394. Because 0 and 394 will make sure that it's actually on the applet. If the applet's 400 big, well, it needs to be 394 because our width is 6. So this accomplishes what we need. We can do the same thing for y then, just copy, paste, change this guy to y, and now we have a random position at startup. We'll create one more method that essentially does the same thing. We'll call it public void change position, so that every time the snake hits a token, we'll just create a new position for the token, move it, and then we'll increment the score. And now the next big method we need to add in here is public boolean snake collision. So this tells us if it has collided with the snake, meaning that the snake has ran over the token. First thing that we'll do in here is we're going to create a snake x and a snake y that just shows the x and y position of the head of the snake. We already have a nice method to do that. We can say snake.getX, and that returns the x position of the head of the snake. So we can actually do the same thing for y equals snake.getY. But now we need to be careful with this. This returns the xy position of the first rectangle. But remember, the rectangles are drawn from the top left corner of that rectangle. So I'm actually going to modify this. I want to know what the exact center of the rectangle is. And if I want to know what that is, I need to add 2 to both of these. The rectangles are 4 by 4, so half of it would be 2. So if I go over 2, down 2, that will give me the exact center of the rectangle. Then I'm going to use that to compare to the token to see if the snake has collided with the token. This next part is a bit tedious to code, so I'm going to paste it in here for you. All this is doing is just comparing the x value of the snake to the x value of the token. And I set this up so that if any portion of the head of the snake touches any portion of the token, it counts as a hit. So it could have a 1 pixel overlap, doesn't matter, it's going to count as a hit, it'll move the token and increment the score. Inside of here we just have change position. We wrote this earlier. I'm just making a call to the method called change position right here, so that once you hit, it'll change the position of the token will go somewhere else, and then you can try and hit the token in its new position. Then we have a score plus plus. Score is just our instance variable for how many tokens you've collected, and then we'll finally return true if it's hit the token or false if it hasn't. Okay, so we're almost there. The game is almost complete. Let's go back to Snake game now, and we'll just add in a token. So up here we'll say token, token. We'll instantiate right next to our snake. We can say token equals new token, and we'll pass the snake as a parameter. Inside of here, if the game is not over, then we'll draw the token. Just the same way we drew the snake. Alright, looks good. Let's go ahead and run. Everything looks good. There's our snake. There's our token. And now everything looks functional now that the token is in there, but you could run over the token and it still won't move. So let's add that functionality in before we go any further. This is going to take place inside of the run method of snake game class, and we can just put it right after check game over. We can say token dot snake collision, and if the snake collision occurs, then it will actually move the token. And now we can go ahead and run. There's our token. Let's go run over our token. Okay, looks good. We hit it. It moved. Let's hit another one. Yep, looks good. Functionality looks good. I was even close to that one. It didn't hit the token. Everything looks good. And now the big piece of functionality that we're missing is that when you hit a token, the snake should get longer and make it more difficult to keep maneuvering your snake around the screen. So in the snake class, we already have this elongate Boolean variable that we never really used. Well, we need to make a mutator for that so that we can alter this Boolean variable in the token class. So let's say public void set elongate. We'll take in a Boolean, then just assign it to the elongate instance variable. Looks good. Now let's go into token and go to that snake collision method that we have. If the snake collides with the token, then we want to elongate. So we can say snake.setElongate to true. And now we can go back to the snake class. And in the snake class, we're going to go down to the move method. And when we coded this, we actually wrote this and recorded the last point within the snake, but we never used it. Well, now we're going to use it, and we're going to say if elongate, meaning if we should make the snake longer, we're going to add on that last point again. So we'll say snake points dot add last, and we'll just keep that last point there. Even though the rest of the snake has moved forward, we'll keep the last point the same, so it actually just adds one onto the end of the snake. Finally, we'll set elongate back to false, and now we should be able to run. And once we hit a token, it should make our snake longer. Yep, looks good. If you hit it straight on, you should see the pixel, well, the rectangle being added on. Yep, there we go. Alright, we're almost finished. The last thing that we need to do is just record the score, meaning that when I hit a wall or hit myself, then it should show the score and how many tokens I've collected. And this is nice and easy to do. Inside of snake game, we're going to go into the paint method, and we're just going to add one more line after game over. So we'll say graphics draw string, and we're going to put score plus, we can pull the score from that token that we have instantiated, so just token get score. Now I'm going to keep the X the same. I'll just increase the Y to 170 so it puts the score right below the game over. So let's test this. There's one token, there's two tokens, there we have it, game over, score is 2, everything looks good. Alright, and that completes the functionality of the snake game, and that's as far as I'm going to take you. The last thing that I want to show you is just how to speed up your snake. make the game more difficult. If you change how long this thread will sleep for, the smaller you make it, the faster your snake will go. So let's crank it down to 30. Let's go ahead and run. Now we're a little bit faster. We could probably make it faster yet. Let's crank it the whole way down to 20. And go ahead and run. Okay, now we're moving pretty quick. You could put this the whole way down to 5 and just be flying across the screen if you wanted to. But alright, I hope you enjoyed it. Hope it helped you become a better programmer. Thanks for watching.